All right, hello everyone. This is grade 7, module 5, which has to do with statistics and probability. In this lesson, the title of this lesson is Chance Experiments. So students start to understand the meaning of probability. That probability is how likely it is that an event will occur. They also learn that probability is always a number that's between 0 and 1. So we say that the probability of 0 means that the event is impossible, and that a probability of 1 means that it's a certain event. And throughout the lesson, they use those terms, certain, impossible, probability, but they were also introduced to the probability scale. And basically, the probability scale is a number line that goes from 0 to 1, and they say that the event is impossible if that probability is 0. So for example, let's say we have a bag with 4 marbles inside, all white marbles. We say that the probability of selecting a black marble is 0. It's impossible to select a black marble. On the other end of the scale, we say that the probability is certain, or 1, if in that bag we have 4 white marbles, and they ask what's the probability of selecting a white marble. So every single time we reach our hand into that bag, we're going to pull out a white marble. Right in the middle of the number line, or in the probability scale, is that 1/2. And the probability of 1/2 means that the event is equally likely to occur or not to occur. So for example, if we have 2 black marbles and 2 white marbles in a bag, the probability of selecting either black or white marble is equally likely because there's the same number of black and white marbles. During the lesson, students were also introduced to 2 other terms. One term is unlikely, and the other term is likely. So unlikely, we say that the probability of an event is unlikely if the probability is between 0 and 1/2. So for example, let's say I have this spinner, and I spin this spinner. There's 3 red sections on this spinner and only 1 blue section. So it's unlikely that that spinner is going to land in a blue section. It's not impossible. It can happen, but it's unlikely that it will land in the blue section. On the other hand, if I spin that spinner, we say that it's likely that that spinner is going to land in the red section because there's more red sections. There's 3 red sections as opposed to 1 blue section. It's not certain that it's going to land in the red section, but it is likely. They look at some sample questions where they match the terms impossible, unlikely, equally likely to different spinners. So here's sample question number 1. It says match each spinner below with the words impossible, unlikely, equally likely to occur or not occur, likely, and certain to describe the chance of the spinner landing on red. So let's say we have these 4 spinners. We want to think about which one is impossible for it to land on red. Well, I notice that this spinner right here is all blue. So it's impossible to land on a red section. There are no red sections. On the complete opposite side, it says which one is certain to land on blue. Well, or I'm sorry, to land on red. This one is all red. So wherever I spin the spinner, it's going to stop on a red section. It's guaranteed to stop on a red section. Now we have the term, let's look at the term equally likely. Equally likely, just when we saw the marbles, we saw that half the marbles were red and half the marbles were white and half the marbles were black. We want to know which one is equally likely to land on red. So I look at these spinners and I see this one, half is red, half is blue. So it's the same chance that that spinner is going to land on a red section as it is a blue section. Now which one is unlikely? If something's unlikely, it's the smallest chance that it can occur. So I want to look for the smallest red section. And I see this one there's 1, 2, 3, 4, 5. There's 5 sections in total, but 4 of those 5 sections are blue. Only 1 section is red. So it's unlikely that this spinner is going to land in red. It's not impossible. See, when I spun this, it landed in red. It's not impossible, but it's unlikely that it's going to land in red. And finally, which one is likely to occur? So I'm looking for the largest red section. 2 out of those 3 sections are red. So it's likely that my spinner, when I spin this, is going to land in a red section. It's not certain, like this one, which is all red, but it's likely because the majority of my spinner is red. All right, the next sample question is like number 2. And again, it uses the term impossible, unlikely, equally likely, likely, or certain to occur. But instead of spinners, this time they ask us about different situations. So the first situation is what the probability that a red cube is drawn from a bag of 10 red cubes and 10 blue cubes. Well, since we have the same number of red cubes as we do blue cubes, notice there's 10 red and 10 blue cubes. It's the same number, so that means it's equally likely to land on a red section as it is a blue section. Okay? The second question says, what's the chance of, well, let's change the color here. Okay. Let's change that to red. There we go. Okay. Second question says the probability that a blue cube is drawn from a bag of 20 blue cubes. So imagine in my bag there's 20 blue cubes. Every single time I reach my hand into that bag, I'm going to get a blue cube. So the question asks now, which one is, whether this is likely, equally likely, impossible, or certain to occur. Well, every time I reach my hand into that bag, I'm going to get a blue cube. So this is a certain event. It's always going to happen because all of my marbles are blue. All are blue. Okay. Question C says a blue cube is drawn from a bag of 20 red cubes. So if I have 20 red cubes in my bag, there's no blue cubes in there, so I cannot pull out a blue cube. So it's impossible that I can pull out a blue cube. It's impossible. And it's impossible because there are no blue cubes. There are no blue cubes, so it's impossible to pull out a blue cube. All right, let's change the color there and make it stand out a little bit more. All right. So now they're looking at the words. So it says, what's the probability that a consonant will be picked when a letter is randomly selected from the word math? Well, if I notice there's, let's see, there's 4 letters in the word math, but only one of them, or 3 of them rather, 1, M, T, and H, there's 3 consonants. So there's 3 out of 4 that are consonants. That's a pretty good chance that I'm going to select a consonant. So in this case, the probability, it's likely that I will pick a consonant because most of the letters are consonants. Oops, I don't know why I changed the font there. There we go. Most of those letters are consonants. Okay. And finally, a vowel is selected from the word smart. So if I look at my word smart, I see there's only one vowel. So 1 out of those 5 letters are vowels. That's not very likely. So it's not likely because most are not vowels. Okay. So that's very similar to sample questions number 2 on the homework. Okay. Let's take a look at a few more. Question 3, sample question 3, gives us a rectangle with about 10 shapes inside, and it says a shape will be drawn at random from the box shown below. It says decide where each event will be located on the probability scale. Then place the letter for each event on the appropriate place of the probability scale. So I have 10 shapes. I look at these quickly and I see that there's 5 hexagons. So there's a lot of hexagons in here. Not many trapezoids, only one trapezoid. So the question says, what's the probability that a closed figure or a polygon will be drawn? Well, I know every single shape that I have in here, a square, a triangle, a hexagon, a trapezoid, they're all polygons. So it's certain that I will pull out a polygon. What's the probability that a red hexagon is drawn? Well, if I look at this, I see there's 1, 2, 3, 4, 5 shapes that are all red hexagons, and there's 1, 2, 3, 4, 5 shapes that are not red hexagons. So it's an equal amount that are and are not red hexagons. Since there's an equal amount, we say that that's equally likely to occur. Question C says, what's the probability that a circle is drawn? Well, when I look at my shapes, I don't see any circles in here. So it's impossible to pull out a circle. And finally, a green trapezoid is drawn. Well, there is only one green trapezoid out of those 10 shapes. So that's not very likely. So we know that 1 out of 10, if we write that as a fraction, 1 out of 10, that's kind of right over here on our probability scale. So it's unlikely that that's going to happen. So I'm going to put this right over here. It's not impossible. So I'm not going to put out the 0, but it's unlikely that it's going to happen. Okay? And the final question, questions 4 through 7 are very similar to this. They give us a bunch of squares, and they ask us to color the squares based on the different situations. So this one says, color the cubes below so that it will be likely, but not certain, to choose a red cube. Well, right away, I see there's 1, 2, 3, 4, 5, 6, 7, 8. I see that there's 8 cubes here. All of those cubes are white. So right now, it's impossible to pick a red cube because every single one of those cubes are white. Right? But if I start coloring in some of those cubes, so now here's 1 red cube, right? 2 red cubes. Notice now it's not impossible to select a red cube, but it's definitely not likely. It's kind of unlikely to select a red cube because there's so few red cubes. So if I keep coloring in those red cubes, now what do we notice? Well, now there's 4 red cubes and there's 4 cubes that are not red. So right now I can say that it's equally likely because there's 4 that are red and 4 that are not red. But I want it to be likely. So as long as I color in 1 more cube, now I have 5 that are red and 3 that are not. So that's a better chance that I pull out a red cube. So as long as I color in either 5 or 6 or 7 cubes that are red, that means that it's likely. Why don't I want to color in all 8 cubes? Well, if I color in all 8 cubes, that means I'm certain to pull out a red cube. And it says that I want it to be likely, but not certain. Okay? And that's very similar to questions 4 through 7 on the practice set. Feel free to take a look at lesson 2 tomorrow, which continues this idea of probability.